Okay, in this video, we're actually going to go ahead and divide this problem out using both synthetic division and polynomial division. I always like to show the parallels between these two because I think usually some people are able to understand one side or one form better than the other, but often when you compare them side by side, I think it makes it a little bit easier for understanding. So let's go ahead and perform the polynomial division portion first, polynomial division first. So when I perform a polynomial division, I want to set this up into a long division format. But remember here, I am missing some terms written in descending order. So I have to write them in. So I have to write a plus 0x squared plus a 0x, and then I have my 27, my negative 27 down at the end. So I have to make sure to write those terms in. We're going to start off our division process. We're going to say what times x gives you x cubed. That's going to be a value of x squared. We're going to take our x squared and multiply it times the x minus 3. And I'm left with x cubed minus 3x squared. And in this circumstance, we know we're going to have to change our signs because we're subtracting. So this becomes a negative x cubed, and this becomes a positive 3x squared. And now our process will be to add and subtract. So we're going to take x cubed minus x cubed. That gives us 0. 0x squared plus 3x squared gives you a value of 3x squared. And now we're going to bring down our positive 0x. And this could be a negative 0x or positive. It doesn't matter if it's negative or positive, but I always like to use positives. I'm a happy type of person. So we're going to start from the beginning. What times x gives you 3x squared? That's going to be a value of 3x. Multiplying the 3x through our divisor, we're going to have 3x squared minus 9x. X times 3x gives you 3x squared, and negative 3 times 3x gives you negative 9x. But remember, I'm going to have to change my signs. I have to change my signs, so that becomes negative. This becomes positive. So now we are going to have 3x squared minus 3x squared gives you 0. 0 plus 9x gives me a value of positive 9x. And now I'm going to bring down my negative 27. Start from the beginning. What times x gives you positive 9x? That's a value of positive 9. Multiplying that positive 9 through the divisor, we're going to have a positive 9x. 9 times negative 3 gives you a value of negative 27. But again, I have to change my sign, so this becomes negative and this becomes positive. 9x minus 9x gives you 0. Negative 27 plus 27 also gives me a 0. Therefore, we know that x minus 3 is a factor. Therefore, x minus 3 is a factor of x cubed minus 27. And this actually equals to x squared plus 3x plus 9. So this division question is equal to that. And we know, and that's a 27, sorry, that's a 27. We know that if x minus 3 is a factor, then x minus 3 can be set equal to 0, and we know that x equaling to 3 is a 0, of that x cubed minus 27. We know that graph is going to either touch or cross when x equals to 3. So now, if we want to perform the synthetic division, the synthetic division is very similar in performance. However, it's a slightly different structure. The first thing that we identify in our synthetic division is we need to have a test 0. So here, this is our factor that we are dividing. Therefore, our test 0 is a value of 3. We can set x minus 3 equal to 0, and we add 3 on both sides, so we're testing x equals to 3. So that's going to be our test 0, And I often like to write to the left. I like to write the factor that I'm testing, so that's going to be an x minus 3 here. So notice now we have to write our coefficients in descending order. So I'm gonna identify our coefficients here. So if we look here with this x cubed and the minus 27, notice I'm missing some terms. So I did have a positive x cubed, but then I have to add a 0x squared and a 0x and a negative 27. I have to make sure we add that. And notice here that was also mimicked in our synthetic division. We had a positive 1x cubed, a 0x squared, a 0x, and a negative 27. We had that 1x cubed, that 0x squared, that 0x, and that negative 27. So we have to write those same coefficients for synthetic division in descending order. So I'm going to write a 1 from the x cubed. I write the 1 from the x cubed. I write the 0 from the x squared. I write the next 0 from the x. And I write the negative 27 from the constant. And now we're going to perform the algorithm. We bring the 1 directly down like such. Take the 3, multiply it times the 1, and this equals to 3. And we always add the vertical columns. 0 plus 3 gives me a value of 3. Take the 3, multiply that times this 3, and we get a value of 9. We get that to be a value of 9. We always add our vertical columns. 0 plus 9 gives us another value of 9. And now we're going to take this 3 here, and we're going to multiply it times this 9, and we're going to get a value of 3 times 9, which gives me a value of 27, and we're going to add our columns together. Negative 27 plus 27 gives me a value of 0, so we get that 0 value remainder just like we did down here. So now, what does this mean? What does this mean? So this means that 3, x equals to 3, is a 0 of x cubed minus 27. And then we have to figure out what all this stuff means. What does all this stuff mean? So notice here we have a 1, we have a 3, and a 9. Notice this is a 1, this is a 3, and this is a 9. So we're going to take our largest exponent term, which is that 3, and we're going to subtract by 1, so we would get an x squared. So we're going to write that in descending order. So this will be an x squared, this will be an x the first, and this is our constant. And notice our signs are consistent, so we're going to write this to be more specific and say we have a positive 3x to the first and a positive 9. And notice we have a positive 3x to the first and a positive 9. So in reality, this indicates that x cubed minus 27 will equal to this x minus 3 times x squared plus 3x plus 9.